Hey guys, welcome back to another video. In today's video, I'm going to be discussing the chain rule with a function that has multiple compositions. So let's begin. So right here we have the derivative of cosine, of sine, of square root, of tangent, of cotangent, of pi x. So to help us solve for this derivative, we're going to be using some trigonometric derivative formulas shown down here. If you want to remember them, you can screenshot or just write them down. But I'm going to move on in 3, 2, 1. So to start off, chain rule is essentially you have some composition function. So let's say we have f of u and u is a function of x. So the derivative of that is that you take the derivative of f but keep u the same and multiply by the derivative of u. So essentially you differentiate the outside function and you keep the inside function the same and you multiply by the inside function. So let's show this here with this derivative. So we have the outside function of cosine. The derivative of cosine is just negative sine, but as I stated earlier, you keep the inside the same. So we have sine, square root, tangent, cotangent, pi x. So now we take the derivative of the inside, which is this part. So we multiply. So in chain rule, you multiply by the inside each time you differentiate. So now let's multiply by cosine, because the derivative of sine is cosine. Cosine square root of tangent, cotangent, pi x. Do the same thing again, but this time you're taking the derivative of the square root of tangent. But this is just the same thing as tangent to the power of 1/2. And if you recall from power rule, to differentiate something raised to some power, you take the power down, you keep the inside the same, cotangent pi x, but you subtract 1 from the degree. So now we have tangent to the power of negative 1/2 of cotangent pi x, and then you would multiply by the derivative of the inside. The derivative of tangent is secant squared, keep the inside the same, and then you multiply by the inside. So now we have the derivative of cotangent, which is negative cosecant squared of pi x. Then you take the derivative of pi x, which is just pi. And when you simplify, these signs are going to cancel out. This term is going to go to the denominator, because anything to a negative exponent, you're basically just dividing by it. You would be left with pi sine of square root of tangent of cotangent of pi x multiplied by everything else divided by 2 square root of tangent cotangent pi x. So this term right here at the bottom is this one that I drew an arrow to, and the 2 on the bottom comes from the 1/2. And the pi just went over here, and since the negative signs canceled out, it just became positive. Thank you for watching, and stay tuned for more.